right, now we're going to switch to trig. So for this first unit, you're going to have the unit circle memorized, which isn't very difficult if you notice the patterns and think about the patterns. You'll need to know the quadrants, in which quadrants the trig functions are positive and negative, understand what a reference angle is, what coterminal angles are, trig ratios, the basic trig identities. Now remember, for much of this stuff, you'll actually have a note sheet you get to use, so some of this is not memorization. The 6 basic trig ratios you'll need to memorize, but the basic trig identities, the equations for sectors, those will be on the note sheet that you have. All right, let's get started. So for the unit circle, notice I have color coded. Everything in orange are 30 degrees away, are the 30 degree. Let me see. I can do this. All right. Okay, our 30 degree reference angles. And notice 30 degrees away, which is, by the way, pi 6. 30 degrees away in the second quadrant is 5 pi 6. 30 degrees away in the third quadrant is 7 pi 6. And 30 degrees away, and you'll have the note sheet, you probably have it now, is 11 pi 6. So all the 30 degree reference angles are the pi 6s. And the reason we call it a reference angle is that, and I think one of the next slides, there's the definition, but a reference angle is between the x-axis and where the angle ends. It's called the terminal side. So from this reference angle to right here, that's a 30 degree angle. From, I don't want to mark this up. So if you have a circle and you go from all the way to here, that's 210 degrees. Well, it's 210 degrees, but this angle right here, from here to 180 degrees, that part is a 30 degree reference angle. So when we're talking about reference angles, that's what we're talking about. All right, back to the unit circle. Notice all the purple, everything that I have color coded in purple are the 45 degrees. So 45 degrees, well, 45 plus 45 is 90, and that's its own category, but another 45 is 135 degrees. Another 45 is 180 in its own category. Add another 45, you're at 225 degrees. 270 is part of the halves category, and then another, and all of those are versions of pi fourths. So pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. And notice at the pi halves and at 180, those are pi fourths also, but look at 2 pi fourths, well, that cancels to pi halves, and pi halves is kind of its own category. In between 3 and 5 is 4 pi fourths, which is pi, which is 180 degrees, kind of its own category. And then finally, down here at 7 pi fourths, between 5 and 7 is 6 pi fourths, and that simplifies to 3 pi halves. Okay, and then the other thing you need to notice are not only the angles somewhat similar, but if you look at their coordinate points, so if we look at the pi 30s, notice the x value, also called the cosine value, is root 3 over 2, and the sine value, also the y value, is root 1 over 2. But remember, root 1 is 1, so 1/2. We'll look over here in the second quadrant, in the third quadrant, in the fourth quadrant. The only thing that has changed is the sign. In this quadrant, the root 3 over 2 is negative. Well, look at that quadrant. The x is negative, the y is positive. And then the third quadrant, they're both negative. negative root 3 over 2, negative 1/2. In the fourth quadrant, root 3 over 2, positive root 3 over 2, because we're in this direction, and then negative 1/2. The other thing I want you to notice is you look at the coordinate points. So let's look at the x values. Root 3 over 2, well, notice all of them except for at, oh, I didn't put this coordinate point right there. Here, let me do it. Whoops, let me do this. With except for at the axes, all of the rest of them have 2 as the denominator. So you don't really have to memorize that. If you know, if well, I guess that's kind of memorizing. But then look at this pattern. Roots in the numerator, root 3, root 2, root 1. And then you go to the y value, and it's the inverse, root 3, counting down, root 3, root 2, root 1. And then if you flip that over the x-axis, look at what we have. Here's the root 3 over 2, here's the root 3 over 2, and then root 3, root 2, root 1. And then go to the y's, root 3, it counts up, root 3, root 2, root 1. And if you take this first quadrant and you flip it over the y-axis, this root 3 over 2 and this 1/2, look at negative root 3 over 2, positive 1/2. And that's the pattern. So if you can memorize these coordinate points and then remember these signs, that's kind of what you need to remember. And remember that all of the pi 6s are 30 degrees away from the x-axis. All of the pi 4ths are 45 degrees away from the x-axis. So 45 degrees up from 180 is 135. 45 degrees more than 180 is 225. For 360, 45 degrees up from 0 is 45. 45 degrees back from 360 is 315. Right? And all of the pi thirds are 60 degrees away from the x-axis. Okay, let's go ahead and go on. So, and then you need to know the quadrants, and we count counterclockwise and only in Roman numerals. If you tell me that that's the one quadrant, you'll lose full points. So first, second, third, fourth in Roman numerals, and then notice the sign. The x and the y value, those will both be positive. And all of the trig functions then will be positive. Sine, cosine, tangent, cosecant, secant, cotangent will all be positive if there's an angle in the first quadrant. Well, let's look at the second quadrant. The x value is negative. The y value is positive. Negative, positive. And in this quadrant, the sines and the cosecants are all positive. The opposite over hypotenuse or hypotenuse over opposite, those are all positive. Third quadrant, Roman numeral 3, tangent and cotangent are the only ones positive, because remember, tangent is opposite, well, opposite is the y value, or the sine value, over adjacent, which is the x over adjacent. Well, negative divide negative is positive. Cotangent is the flip of that, and it will still be negative over negative is positive. So only tangent and cotangents are positive in the third quadrant. And finally, the fourth quadrant, remember, we went to the right of the x-axis and we went down. So in that quadrant, the x's are positive, the y's are negative. All right. Reference angles. So this one right here, I'm going to call that pi 6 or 30 degrees. This is a 30-degree reference angle. However, okay, sorry about that. I realized I hadn't saved this PowerPoint yet, so I paused to do that. So reference angles are acute angles between the x-axis and a terminal side. So I'm going to show you something, because it really can get a little bit confusing. So let's say I go all the way to here. Well, all the way to here is 225 degrees, or 5 pi fourths. Well, the reference angle is this acute angle between the x-axis and the terminal side. So at 225, this is the terminal side of the angle, but between the terminal side and the x-axis, that's the reference angle. And it's never a negative. Reference angle is kind of like the absolute value, the distance between the x-axis and, so the terminal side subtract the x-axis or something like that. In fact, here for the third quadrant, here's the formula. It's the terminal angle, so 225 degrees, subtract 180. Well, that reference angle then is a 45-degree angle. So when you're talking about reference angles, so if we went from here all the way around and I did this, well, that right there might be 300 degrees. Well, now look at what this says. For the fourth quadrant, you do 360, subtract 300 degrees, and you get a 60-degree reference angle. So remember, it's between the x-axis. So in this case, don't let yourself be fooled into thinking that this is the reference angle. It is not. It is always between the x-axis and the ending or the terminal side of the angle. Okay, coterminal angles now are angles. So here we have this 30-degree angle. Well, if we go from here all the way around the circle again, well, all the way around the circle is 360 or 2 pi. So you would take 30 degrees and you would add 360 degrees and you would be at 390 degrees. 390 degrees and 30 degrees they are coterminal angles because they sit at the exact same location. They're in the same quadrant at the same angle. They share the same reference angle. That might be the best way to describe that. And if we had this in radians, so pi 6, all the way around the circle is 2 pi. Well, if 6 is in the denominator, that's the same thing as 12 pi 6. See that? 12 divided 6 is 2. Then we would be at 13 pi 6. So 13 pi 6 and pi 6 are coterminals. They have the same reference angle. So this angle, 30 degrees, is the same as 390. If you took 30 degrees and subtracted 360, so you would get negative 330. So if we started here and we went clockwise, which is this case backwards, that would bring us to negative 330 degrees. And negative 330 and 30 are coterminal. So how you find if angles are coterminal, you take the angles that you start with and you either add or subtract 360 or add and subtract 2 pi, right? Degrees versus radians. Most of the time, when we're talking about angle measures, we're talking about degrees. But when we want to talk about the arc lengths, so if you have a circle, this arc length right here, typically we're going to describe that in radians. And if we want to find the area of that sector right there, we would need, or this arc length measure, you would need to put the theta in radian measures, not angle degree measures. Because as soon as we're finding any kind of length or an area, this is the measure that we need. Now to convert. So you start off with your, whatever your angle is in degrees, and when you're going to convert it to radians, this is how you do it. You take your degrees and you multiply it by pi over 180. When you do that, the degrees cancel. And then So let's say you had 30 degrees times pi over 180. Well, the degrees cancel because labels cancel. And if you type in your calculator 30 fraction 180, well, 30 goes into 30 one time, so that's 1 pi. 30 goes into 180 6 times. Oh, look at pi 6. And I already mentioned 30 degrees is pi 6. And to convert back, you take your radian measure, so pi 6 times 180 degrees over pi, and notice the pi's cancel, and 180 degrees divided by 6 gives you 30 degrees. All right. Trig ratios. You do need to memorize these. Take that out of red. Okay. And it's a reference point to the theta that you'll be looking at. Okay. So from the reference point of this theta, well, first of all, we're talking about right angles right now. Right triangles only for right now. All right. And from this theta, this right here is the opposite side, also called the y side or the sine side, because sine is opposite over, this is the hypotenuse. The side opposite always a right angle is the hypotenuse side. And if we were to label this point right here, this coordinate point, well, another way to look at that is that's the adjacent side, and this would be, so this entire side right here, respect to that theta, is the side adjacent, but this entire length right here is the x length. This entire length is the y length, but it's also that entire length is the opposite side. And this is the hypotenuse. So sine, in the SOHCAHTOA, sine is opposite over hypotenuse, or y over whatever the hypotenuse value is. The ka part, cosine, is adjacent over hypotenuse. So adjacent over hypotenuse. And then we have tangent. Tangent is opposite over adjacent. So opposite over adjacent. So sine, opposite over hypotenuse. Its inverse is cosecant, hypotenuse over opposite. Cosine is adjacent over hypotenuse, or x over hypotenuse. Its inverse is secant, which is, look at, they're reciprocals of each other. Hypotenuse over adjacent, or hypotenuse over x. And then tangent is opposite over adjacent, also called y over x, or sine over cosine. That's another way to think about it. And cotangent, in fact, this is an identity, tangent theta. We'll get to that in a second. And then cotangent is a reciprocal of tangent, so its ratio is adjacent over opposite, or x over y. These 6 trig ratios you do need to have memorized for our first unit test and for a quiz that you will take either on the day of finals or maybe when we get back from break. All right, basic trig identities. Sine is the reciprocal, or sine and cosecant are reciprocals of each other. So remember, reciprocals, if you have 1 over 2, the reciprocal would be 2 over 1. So sine is 1 over cosecant. Cosecant is 1 over sine. Cosine is 1 over secant. They're equivalent. Secant is the equivalent of 1 over cosine. Tangent is 1 over cotangent. It's also referred to as sine over cosine, or y over x. Cotangent is, these are reciprocals, 1 over tangent, or cosine over sine, or the x value over the y value. Pythagorean, these are starting to get into the identities. And remember, if we have a right triangle, to find this distance, remember the distance formula, distance is equal to the square root of x squared plus y squared, or this distance squared plus this distance squared. Well, what also, we have the equation for a circle. x squared plus y squared is equal to r squared. And to find r, you take the square root, kind of like distance. You take the square root to find distance. Well, Pythagorean theorem, remember on right triangles, is a squared plus b squared is equal to c squared, right? Well, if this is your theta, this is opposite, this is adjacent, the opposite side, remember, the y relates to sine, so sine squared plus cosine squared is equal to 1. When you have a unit circle where every radius is a length of 1 unit. Now, if you had a circle with a radius bigger than 1, then that would change a little bit. But usually when we're just working with the trig identities, we're working with the unit circle, and it's called the unit circle because each radius is 1 unit. All of the radii are 1 units. All right. So if you have this sine squared plus cosine squared is equal to 1, which is very similar to the distance or the circle formula, or Pythagorean theorem, a squared plus b squared equals c squared, to find out what sine is, subtract cosine from both sides, then take the square root. And then remember, 1 subtract x squared, that's the difference of squares. That would factor to 1, so if this were cosine squared, 1 minus cosine, 1 plus cosine, and then take the square root of that. All right, and then you've got tangent, another Pythagorean trig identity, tangent squared theta plus 1 equals secant squared. And if you want to know what tangent is, just subtract the 1 on both sides. Secant squared theta, subtract 1. Or if you want to know what 1 equals secant squared, subtract tangent squared. And then you've got cotangent squared theta plus 1 equals cosecant. And you could do the same thing with cotangent that I did right here, but I just ran out of room. All right, then we're going to be graphing trig identities. You'll have this on the note sheet that I gave you. So in first semester, when we were doing all of the transformations, when you had an a out here, and then maybe the bx plus or minus c to the n power plus or minus d, right? A was the vertical stretch or compression, depending on if it was a fraction or integer. D was a vertical shift. B was the horizontal compression or stretch, depending if it was a fraction or decimal. And the C value for the horizontal shift, it was the opposite of C divided by whatever the B was. And all of those are the same for these graphs. It's just, notice in red, that's the basic parent function. So the basic parent function for sine looks like this, cosine, and cosine is just off 90 degrees. If you move this 90 degrees to the left or the right, those would have the same graph. And then tangent, you've got some vertical asymptotes at negative pi halves and pi halves. Cosecant, which is the inverse of sine. So wherever sine has a peak, notice I highlighted in yellow. The yellow part for the sine graph is the secant graph. And then they will have some asymptotes. So remember, cosecant is the same as 1 over sine. Well, when the sine value is 0, 1 over 0, there will be asymptotes. And secant is the reciprocal of sine. So when cosine is 0, you'll have some asymptotes. And remember, tangent is sine over cosine. So wherever cosine is 0, you're going to have asymptotes. And cotangent is cosine over sine. So wherever sine is 0, you will have the asymptotes. Yep, and here are the transformations. And I also told you the domain. Well, the sine and cosine graph, so the sine graph does this, and it infinitely goes on in both directions, right? The cosine graph, let me change the color. starts here, and it goes infinitely both directions, but look at their heights. So for the sine graph, so the lowest point down here is -1, the highest point is 1. So that is the range. They fluctuate from the highest point being at a height of 1, the lowest point being at -1. And then remember, I'm just giving you the domain and range for the tangents, or for the sine, cosine, tangent. Tangent goes on repeating patterns between the pi halves, right? So between negative pi halves and pi halves, that's a domain. And then there's another domain between pi halves and 3 pi halves. And then from 3 pi halves to 5 pi halves, and so forth. Okay. Or actually, that's a full pi. So yeah, 3 pi halves. Okay. Then finally, area of a sector. So if I tell you that this is a 45-degree angle, well, in order to find this arc length, I need to put that theta in radians. So if you look at the unit circle, if you have that memorized, you know that it's pi fourths. But if you don't memorize things easily, then use the formula. 45 degrees times pi over 180. The degree symbols cancel, leaving a pi. And then just in your calculator, 45 fraction 180, you end up with 1/4. So pi fourths. And then the formula to find the arc length formula right here. Let me change that color. S represents arc length is equal to the theta for this angle. It's pi fourths times, and if I tell you this radius right here is 2 feet, then you'd multiply that by 2 feet, arc length. So we know that there's going to be a pi and there's going to be a feet, and then 2/4 simplifies to 1/2. So arc length is pi halves for this angle with this radius is pi halves feet. And if I said, okay, I want you to find the entire area of that sector, I now use the formula. We still have to use the radians. So area is, it's the theta, pi fourths, times the radius, so 2 feet, squared, divided by 2. Yep. And so then 2 feet squared is 4 feet. 4 feet divided by 2 is 2 feet. And then remember, the feet will be squared. So we'll have pi feet squared. So what did I say? I said pi fourths. And then that's 4 feet squared over 2. Well, the 4's cancel. We could do it that way. And look at, we're at pi halves. Well, that's an interesting one. So what did we say the arc length was? The arc length was pi fourths times the radius, and that canceled to pi halves. I'm glad I did that one, because that doesn't happen very often. Almost never will the arc length and the area almost look identical, except for, remember, this is an area measure, and so it's feet squared. This is not the same measure. It just looks that way. All right, that is it for this video. So the things to focus on, memorize everything on this, on the unit circle graph. You have to memorize the quadrant numbers, where all the trig functions are positive, the names of the degrees, so the degrees, the radians, the quadrants, and the coordinate points. Now remember, for this first quadrant, it's not only 0 and 360, you also would put 0, 2 pi at 0 degrees. I'm trying to think if there's anything else that I'm missing. And then you would jump down to the trig ratios. Very important to have all of those memorized. And the other stuff is important to familiarize yourself with. There we go. Because you'll need all that information to more quickly solve problems. All right, that is it, and I hope you all did well on your exam.